Okay, it's your stats sensei, and I'm back with some more homework help. So you work for a consumer advocate agency and want to find the mean repair cost of a washing machine. As part of your study, you randomly select 40, we have a sample size of 40 repair costs and find a mean to be $100. From past studies, you know that the standard deviation of the population is 17.5. Because this is a standard deviation of the population, we know we're working with a Z as opposed to a T, and that the population is normally distributed. And it says you may assume that all conditions have been met. Because they told us that, we don't have to list the conditions. It says construct a 90% confidence interval and interpret both the interval and the confidence level. So in this case, we have our equation X bar plus or minus Z star standard deviation divided by the square root of n. So what we're actually going to do is we're going to start off going, well, we need to define our parameter, and it let mu equal the true population mean repair cost. Really should say of washing machines. Now, if you just had repair costs, that would be fine, but technically it's of the washing machine. All right, so we're going to go ahead and work this out, and I'm going to go ahead and draw an image of what we're looking for. And the image is essentially this. We're doing a 90% confidence interval. So in the middle, I'm going to have 0.90, and I'm going to be looking for this X1 and this X2. We happen to have a sample mean of 100. So this is going to be below 100. This is going to be above 100. So I'm going to need some information here. But let's start plugging into our equation and see what we actually have. So what we actually have is we know this is 100. So we have 100 plus or minus. We don't know Z star, so I'm going to leave a space for Z star, and we'll come back to that. We have a standard deviation of our population, which is 17.50, divided by the square root of n, which in this case is going to be the square root of 40. So the question is, how do I get Z star? Well, they gave us an area, and anytime they give us an app, anytime they give you that, you're going to use an inverse norm. So we're going to have to use an inverse norm, which means I need to know this area as well. So I'm going to drop into my inverse norm. We go second vars, inverse norm. And my area in this case is going to be parenthesis 1 minus 0.90, close parenthesis, divided by 2. Mean is 0, standard deviation of 1. And I'm getting a Z-score of negative 1.6448. Now I'm going to go ahead and make it positive, all right? So this is just because it's easier to work with, 1.6448, and you can always make it positive. All right, so now that I have plugged everything into my equation, I can go stat test, and I can drop down to number 7, which is my Z interval. Standard deviation is 17.5, X bar of 100. My sample size was size 40, and we wanted a confidence level of 0.90. I can just press calculate, and there's my answer. So my lower bound, my X is 95.449, and my upper bound is 104.55. So now I've shown my work. And the next thing it asked me to do is and interpret both the interval and the confidence level. So what we have here is when we interpret the interval, it turns out we're 95 or 90% confident, because there's a 90% interval, that the true population mean repair cost of washing machines lies within the interval 95.449 and 104.55, which is what we have here. So that's interpreting the interval, but it also says do the confidence level. When it says that, we mean In repeated sampling, we expect this method to capture the true population mean repair cost of washing machines 90% of the time. Okay, and both of these can be found on our template in the recipe cards. The next thing is determine the minimum repaired sample size if you want to be 95% confident that the sample mean lies within the within $10 of the population. So we're going to go back and we're going to look at our formula, and our formula is essentially X bar plus or minus Z star, the standard deviation divided by the square root of n. And we're looking for a changing of the n. And what we really want to have happen is we want a 95% interval. We know our sample mean is 100, and we want to be plus or minus 10. So we don't want to be more than 110, and we don't want to be less than 90. So I'm looking for what sample size would it take to get an interval of 90 to 110. So we need to calculate a few things. First off, we need to calculate our Z star, which will be inverse norm. So, oh, and by the way, this part right here is known as the margin of error. That's the margin of error, and that part is going to have to equal $10 when we're done. So let's calculate our Z star. So to do that, we're going to go to our inverse norm. So second vars, inverse norm, and we want a 95% interval. So in this case, parenthesis 1 minus 0.95 divided by 2, because we have two tails, mean is 0, standard deviation of 1. And we end up getting 1.9599. So our Z star is 1.9599 equals, because we're only looking at our times, I'm sorry, times 17.50, and that was our standard deviation from above that they gave us, divided by the square root of n equals 10. So I'm going to go ahead and multiply these two things together. 1.9599 times 17.50, and I get 34.2982. And I'm going to use some what math teachers would say is bad notation, divided by the square root of n equals 10. And here we go. We're going to use some very quick and dirty bad notation that works really well. We're just going to we're going to square everything. And the reason we're doing that is we want to get rid of that square root. So I'm going to go ahead and square this top value. And I get 1176. So I have 1176.3699 over n equals, well, 10 squared is 100. To make this easy, I'm just going to put this over 1, and it's like, hey, I have a proportion, so I'm multiplying these two values and dividing by 100. So 1176 divided by 100. Now I end up with n equals 11.76. Whenever you're solving for sample size, so if you're ever solving for sample size, you must always round up. If this had been 11.001, I'd still have to round up to 12. So in this case, we have to have a sample size of 12. And that's my answer. But let's go check this out. It should be no more than 90. It should not be lower than $90, and it shouldn't be greater than 110. So let's rerun this. So stat test, and we're going to go run a Z interval. Our standard deviation is still 17.5. Our X bar, that was our sample means 100, but instead of having a sample size 40, we're going to have a sample size 12, and we're using a confidence level of 0.95. And sure enough, we're not below 90 and we're not below 110. And you're like, well, could we get any closer? Well, the next sample size would be 11. So let's try it. So stats test, Z interval. And if I change my sample size to 11, I end up with 89.6. That's too low. And 110.3. That's too high. Because we had to be no lower than 90 and no more than 110. So the value that works out best for that is 12. Once again, all we did was plug in our, calculate a Z star, plug in that Z star, or multiply these, square the entire thing, and then solve by proportion. This is like the only real math that we really do in this class. All right, number 4. A hardware manufacturer produces bolts used to assemble various machines. Assume that the diameter of the bolts produced by this manufacturer is normally distributed and has an unknown population mean. Suppose that the average diameter of a simple random sample has a sample mean. Oh, that's a key phrase, sample mean. The fact that we're working with a sample mean and a sample standard deviation, not the sample mean, but the sample standard deviation, tells me I'm working with a t distribution. So I'm going to, and it says construct a 99% interval. Well, x bar plus or minus t star s divided by the square root of n. So in this case, let mu equal the true population mean, and we're interested in bolt diameter or diameter of bolts, but mean bolt diameter. All right, so they want us to calculate a 99% interval. So this is what we're actually doing. This area needs to be 0.99, and I'm looking for this value and this value. We have a sample mean, a sample x bar, and that sample x bar is 5.11. At this point, I can, and they told me the conditions have been met, so I don't have to list them. So I can start plugging into this equation. And so I'm going to start plugging into the equation, and I have 5.11 plus or minus. I'm going to leave a space for t star. I'll come back and get that in a moment. S, our sample standard deviation, is 0.1. And they gave us a sample size of 50. All right, so we need to come back and get our t star. So to do that, since the t distribution, instead of using an inverse norm, we're going to use an inverse t. So second vars, inverse t, and my area is parenthesis 1 minus 0.99, and we're dividing it by 2 because we have 2 tails. Then the next thing it asks me for is my degrees of freedom. Well, my degrees of freedom is my sample size, which happens to be 50, minus 1. So 50 minus 1. And we end up getting degrees of freedom equal to, or 2.6799. Okay, that looks really good for work shown. So we're going to go ahead and run this to calculate it. So stat test, and we need to drop all the way down to t interval, which happens to be at number 8. And our x bar in this case is 5.11. Our sample standard deviation was 0.1. Our sample size was 50, and we wanted a confidence level of 0.99. And so we end up getting 5.0721. And that's our lower bound, so that's my x1. And then we end up with a upper bound of 5.1479. So that's my upper bound. So it says construct an interval and interpret the interval. So in this case, We are 99% confident the true population mean of bolt diameters lies within this interval. And so that would be our interpretation. Did not ask us to interpret the confidence level, so we're not going to. But again, we are 99% confident the true population mean of bolt diameters lies within this interval. All right, thanks for watching, and we'll see you in the next video.